Hi, in this video we are going to work on the relation between simultaneous equations and the graphs. But before we dive into this relation, let's remember a few things. Now let's consider the graph of a linear equation. So if I have a point P, say 2 to 1, well, the point P will lie on this coordinate, right? So this is where point P is, and I can also go like, let's have another point Q. It's 1 to 3, right? And then I'll have that point to be here. It's 1, 2, 3, right? So Q is here. Q will be on the graph where P is not on the graph. So about these points and the graph, we can say P does not satisfy the equation. So these two statements are the same. P is not on the graph, meaning P does not satisfy the equation. And for Q, we can say Q satisfies the equation because Q is on the graph, right? So this satisfy verb means the following. When you substitute the x and y coordinate of Q into the equation, you get, for y being 3, right? It's 2 times 1, the x coordinate, plus 1. And you find out as 2 times 1 is 2, plus 1 is 3, so you find something correct. This shows that Q satisfies the equation, whereas for P, if I substitute these values, it's going to be 1 equals 2 times 2 plus 1. So I'm going to end up with 1 equals 5, which is not correct, right? So this is not a correct statement. This shows that P does not satisfy the equation, which transfers to the idea that P is not on the graph, whereas Q is on the graph. So this is one thing that we should keep in mind. Now let's consider this quadratic graph. If y equals 0, then I'll have a quadratic equation, which I could solve by factorizing first. This is minus 2 and not minus 1, 1. And I'm going to end up with x minus 2 times x plus 1 equals 0, from which I'll find x to be 2 and x to be negative 1. So the graph cuts the x-axis from those values, which we call them as the roots. Now, this is what happens when y equals 0. Now let's consider if y is equal to some other algebraic expression. For example, let's say y equals x squared minus x minus 2 and y equals x plus 1. So the graphs of these functions will be as shown. Now, if I write x squared minus x minus 2 instead of 0, if I write x plus 1, because both of these expressions are equal to y, then I can take these to the other side. So algebraically, I can end up with x squared minus 2x minus 3 equals 0, and then that's minus 3 and 1, so that's going to be x minus 3 times x plus 1 equals 0, from which I end up with x equals 3 and x equals negative 1. So the solution to this equation is equivalent to the solution to this quadratic equation, which are as follows. X is 3, x is negative 1. In terms of graphs, this means that these two graphs, the graph of y equals x squared minus x minus 2 and y equals x plus 1, right? These two graphs intersect at the solutions, right? So the first intersection point is here, x equals -1. The second intersection point is here, x is 3. So basically, when you equate two algebraic expressions, or when you equate two functions, the solution of this new equation will be the intersection points of these two graphs of these two functions, right? So that's the relation actually between the algebraic solutions of simultaneous equations, right, and their graphs. Now this is the graph of these are the graphs of one quadratic and one linear. So you could say that this might represent a solution of simultaneous quadratic equations, right? So let's see an example to see how this properly works. Right, this question says that sketch the curve and the line and use the graphs to write down the solutions to the simultaneous equations. So this is quadratic simultaneous equations. You can see one quadratic and one linear, right? Without solving it, without using algebra, just by drawing the graphs, we're going to find out the solutions. So let's see. To be able to sketch, of course, we need to do some calculations. These are the roots for the quadratics, right? And for y equals 0, sorry, for x equals 0, y is 9. So basically, that's going to be 0 to 9. Let's write it here. For the y-intercept. Now for the line graph, it's going to be 0 to 6 and 3 to 0. And if we sketch it, we'll have the following. So basically you can see that the first intersection is here, the second intersection is here. That is probably -1, just because this is a sketch. We cannot accurately say whether it's -1 or not, but most probably it is -1, right? So the solutions would be -1 to 8 and 3 to 0. Now let's try algebraically to solve for these x and y values and prove that we're correct. Actually, this is not asked in the question, but just to show the relation, we're going to do that now. So I have x squared plus y equals 9, and then I have 2x plus y equals 6. So if I play the second one, I'm going to write y equals 6 minus 2x, which will go to here in the first equation. So that first equation will become x squared plus 6 minus 2x equals 9. If I rearrange this, taking 9 to the left hand side as well, it's going to be x squared minus 2x plus 6 minus 9 will give me minus 3, right? And thinking of two numbers multiplying out to minus 3 and adding up to minus 2, I'm going to end up with minus 3 and 1, which I could then factorize, saying that that's x minus 3 times x plus 1 equals 0, from which I can find x is 3, x is -1. See, this we can already see from our graph, and this is what we estimated, and it was true. Of course, while solving algebraically, I should go on and find y values, so I'll use the second equation. It's going to be for x is 3, right? 2 times 3 plus y is 6, so y is 0, obviously. And for x is -1, 2 times -1 plus y is 6. This makes -2. If you send it to the other side, you find y to be 8, which we also estimated. So basically, this is the relationship between the algebraic solution to the simultaneous equations and the graphs of these equations, right? So wherever they intersect, these two graphs, you have the pairs x and y, right? So x is 3, y is 0 is basically the coordinate 3 to 0, whereas x is minus 1, y is 8 is basically this coordinate minus 1 to 8. These are the coordinates of the intersection. So the coordinates of the intersection is the same as the solution to the simultaneous equations. So if you see one of these expressions, you have to remember the other one. Coordinates of intersection is a solution to the simultaneous equations and vice versa. So this concept can appear with the notion of discriminant. So let's look at this example now. Right, this is the line y equals 2x plus 1 intersects with the curve here, and it intersects at one point. Alright, now this is important because if it gives us for this information, like for k is positive, k is greater than 0, then most probably you're going to end up with two k values, one of which will be negative, right? So we are going to come back to this information. Now the questions are, find the value of k and then find the coordinates of the point of intersection. Now, first of all, we'll start with this information. These intersect at one point. Okay, this tells me that the discriminant will be 0 because discriminant was 0 when the graph or the equation has one solution. The graph touches the x-axis only at one point, remember? So where is this quadratic that I'm going to check the discriminant? Because here the given equation is kx squared plus 2y plus k minus 2 equals 0. So we have two unknowns. That is why we are going to substitute this into here. So I'm going to rewrite this equation as k squared plus 2 times 2x plus 1 plus k minus 2 equals 0. Now, if you get rid of the brackets, we'll have k squared plus 4x plus 2 plus k minus 2, right? And these twos cancel each other out. I will have k squared plus 4x plus k equals 0. This is the quadratic equation that I'm going to check the discriminant of, right? So if I write the discriminant being b squared minus 4ac and substitute the values, well, b is 4, so it's going to be 4 squared minus 4 times a is 1, c is k, right? So this will be 16 minus, 4k. Now this must be 0. At this point I realized that I forgot to write x squared here, so let me correct this. So this must be not k squared, but kx squared, right? Therefore, you're going to have the a value to be k, right? So that's going to be k, and this is going to be 4k squared. Now we have a quadratic because I have to go with a positive k value. In the beginning of the question, I said there should be at least, two values of k, one of which would be negative, but I ended up with a linear equation. I literally made a mistake, but just because of this information in mind, I figured it out and I corrected myself. So I have 16 minus 4k squared equals 0. This means 4k squared is 16 and k squared is 4. If I take the square root of both sides, I end up with plus minus square root of 4, which would be plus minus 2, but of course I'm going to end up with the positive value as required. So for k equals 2, which is the answer to part A, now I'm going to substitute that value into the equation and find the point of intersection. Right, so this equation will become 2x squared plus 4x plus 2 equals 0. If you take into brackets of 2, you end up with x squared. Of course, you get rid of the 2 later, and you're going to end up with this, which is basically x plus 1 bracket squared equals 0, where you could find the value of x to be negative 1. So for x is negative 1, y is 2 times negative 1 plus 1, which is minus 2 plus 1, giving me minus 1. So basically the coordinates of the points of intersection is minus 1 to minus 1. And, well, maybe it's worth mentioning, I use this equation which comes from the substitution of the linear equation into the quadratic here, right? This is what I have done a few minutes ago for part A. Right, so in this one, so basically this is the solution, equivalent solution of these two simultaneous equations, and for x equals negative 1, y also equals negative 1, which gives me the point of intersection. Right, so there are two questions here about simultaneous equations and graphs. Please solve these questions on your book and submit your answers online, except for part A, because it's a show that question, right? So you substitute only part B and C for question 2. Now, of course, for question 1, you can't submit your sketching, so you skip part A as well. So you just submit part B. Now notice that both questions ask you to find the coordinates of the point of intersection. So you have to end up with 1 point. Right? That's the hint. Alright. Thanks for watching.